Hello again, everyone, and welcome back. Can you believe that we're already up to episode number 4 in the OpenStack series here on Learn Linux TV? Well, neither can I. Time is just flying by. But then again, doesn't time always fly by when you're having fun? I know I'm having a ton of fun with this series and producing this content for you guys. OpenStack is awesome. Now, in the previous episode, we took a look at concepts relating to storage within OpenStack, and this time around, the subject matter is going to be around networking in OpenStack. When it comes to physical networks, you may already be familiar with those concepts. Traditionally, you'll have switches, routers, and other networking equipment as well. Perhaps you are watching this video while connected to a Wi-Fi access point that itself is connected to a router. And perhaps that router is connected to something like a cable modem which provides your internet access. Now, when it comes to OpenStack, the concepts here aren't all that different. You still have the same components, but the difference here is that you have virtualized versions of those components, basically software-defined networking. So what I'm going to do in this video is tell you all about networking in OpenStack, and it's going to be a ton of fun. But before I get into that, I need to take a moment to mention the sponsor for this entire series, OpenMetal. And without them, OpenStack coverage here on Learn Linux TV wouldn't be possible. So I definitely appreciate OpenMetal for making this entire series a reality. And what is OpenMetal, you might ask? Well, with their platform, you could get set up with your very own on-demand private cloud. And what that means is that you could get set up with your very own OpenStack implementation with their platform, and that'll enable you to skip the long setup process for OpenMetal if you were to build it manually. Why don't you let the experts do it? Because OpenMetal lives and breathes OpenStack. In fact, OpenStack is key to their business and they use it internally. By visiting the URL that you see on the screen right now, you'll be supporting Learn Linux TV, and I'd really appreciate that. But in return for checking out that URL, like I mentioned, you could get set up with your very own OpenStack cloud, and what better way to get set up with OpenStack than to be set up with OpenStack by a company that adores the technology. So thank you so much to OpenMetal for again making this series possible. I really appreciate that. And with all of that out of the way, I'm excited to dive back into OpenStack for this episode number 4 of the 6-part series around OpenStack. Again, this time around, we're going to dive into networking, so let's get started. All right, so the first networking related concept that I would like to go over today is the concept around public networks and private networks. We've been using one of those concepts already throughout the series. Each of the instances that we've created so far have all been made publicly available. And that kind of makes sense because the example that I'm going along with in the examples so far is the concept of a web server, or in our case, a blog server. Unless the server is serving an intranet page, then chances are you want everyone to be able to access that particular website. So therefore, more often than not, a web server is going to be publicly available. And by publicly available, I mean that that server can be accessed by anyone that has internet access, because anyone in the general public will have access to a publicly available instance. So when it comes to private networking or private instances, then it's the exact opposite, something that's not available to the general public. When it comes to data centers, that can mean that you need VPN access to access that particular website. Or perhaps it's something that you only want to use internally inside your organization and make sure that it's not accessible outside your organization. So my overall recommendation is that by default, everything you create should be private. That includes object storage as well as compute instances, basically everything. And only when you have a specific use case that requires a resource to be publicly available, only then should you make it publicly available. For example, if you maintain your organization's website, you probably want that website to be publicly available. After all, most organizations have a public-facing website, and if somebody wants to find out more about your organization, they may visit that website to, well, learn more. If you made the server instance that serves your organization's website private, meaning no one outside your building can get to it, then that server would be orders of magnitude more secure. Public servers, on the other hand, are a huge target for threat actors. So every time you make an instance available publicly, you're taking a risk. But sometimes the goal of the instance requires that the instance is publicly available. Otherwise, in the case of your website, no one would be able to visit it if the server that actually serves that website itself is private. In the case of SSH, we should never, I repeat, never make that available publicly. Port 80 or 443 for your web server is fine in most cases. Those are the common ports that are used to access websites, and without those ports being accessible, then, well, no one can get to your website. However, since SSH is how we manage our servers, it would be terrible if threat actors were able to break into those. So we definitely want to make sure that SSH at least is locked down. And actually, that's the perfect segue to look more deeply into security groups. And security groups are how we manage, in general, outside access to our resources. And we can access security groups here in Horizon by first clicking on Network. We see that right here. And then underneath that, we have security groups, as you can see right here. So I'll click on that. And here we have a list of security groups. And to help you understand this concept, what I'll do is walk you through the process of creating a security group. But before we do that, we should understand exactly what a security group is. Already I've given you some information. We use security groups to control what is able to access our instances. And while that gives us an example of what a security group is, well, what exactly is it? Well, you could think of a security group as a form of firewall, but it doesn't have a footprint that's as large as an actual firewall. In your typical data center, you might have a firewall, maybe a physical firewall, in your server rack that controls what's able to access the servers within that rack. A security group is basically an object that contains at least one rule. That one rule could be to allow everything, to allow nothing, to allow communication via very specific ports. It has to have at least one instruction there that controls access, but you can actually have more than one. One example here is you could create a security group called Web Server. Once you've created the security group, you can attach it to an instance, and you could actually attach it to more than one instance. And then maybe you'll attach that security group to every web server-oriented instance that you might have within OpenStack. That way, rather than defining the rules for access each and every time you set up a new compute instance, what you could do instead is define those rules one time into a logical grouping, a security group, basically, and that security group can contain all of the rules or permissions that pertain to that particular object and its use case. And then you can simply attach that security group to any instance that needs those rules. In the case of a web server, you might want port 80 as well as 443 to be publicly accessible. So what you could do is create a security group that allows access to the server via ports 443 and port 80, but then lock down port 22, which is normally used for SSH. You could lock that down to your local network, so you have to be on site to access it, or perhaps via a VPN. But again, if it's a web server, you probably want port 80 and 443 to be publicly available, so you could absolutely set that up in a security group. So what I'm going to do right now is create a security group that's specific to SSH. And in order to do that, what I'll do is click Create Security Group right here. And what I'll do is name it SSH Access. Now, we already created a security group earlier in the series for SSH, but we're going to ignore that. We want to create a brand new one to illustrate this example. But anyway, I gave it a name. I could also give it a description if I want to. Once I've done that, I could click Create Security Group to make it exist. Once you define a new security group, which is what we've just done, you'll be brought to that security group, the settings for that security group. So in order to make this security group actually useful, we need to create at least one rule. So I'll click Add Rule, and then we can start the process. Now up here at the top, we have Custom TCP Rule. That's the default selection. If I drop that down, we have a number of different selections here that we could choose. Since the default is Custom TCP Rule, then that allows us to build one from scratch. But if any of these selections here actually pertain to what we're trying to accomplish with this security group, we could actually just choose it from the list. In fact, SSH is listed right here. Now we can still manually create the rule if we wanted to. We don't have to choose SSH here if we are creating an SSH security group. This is just offered here as a convenience. But anyway, I'll click on it. And as you can see, we have that selected. Now, if we compare to how that was when we had custom TCP rule selected, we could actually define the port manually. But when I choose SSH, we can see that, well, the option to select the port went away. And that's because by choosing SSH up here, we're actually choosing the default SSH port of 22. Now, if the instance that we're trying to protect was using a different port for SSH, then we would want to create a custom rule. But since we didn't actually customize the port that SSH uses, then we're good to just choose that right here. And as an aside, even though you can choose a different SSH port, when it comes to the SSH service on the server or compute instance itself, it's probably just a better idea to leave it alone, at least in this case, because we're going to control access by security group, so that means this is probably a simpler way to go. Anyway, the next thing we'll do is type up a description. What I like to do is be as descriptive as possible, and that way, if anyone else looks at this security group rule, they'll know exactly what it does. I mean, sure, by the rule being selected as SSH, then anyone probably understands that this rule pertains to SSH. I think the name gives it away as well. However, in the description field, we could be even more, descriptive. So in my case, I'm going to create a rule that allows SSH access from my home office. Now here we'll leave the remote as CIDR, and CIDR is a way that we can define network addresses. I have other videos on my channel that goes over networking, so we're going to keep it relatively simple. But what I want to do is come down here and type in the IP address that I want to accept the traffic from. If I was to leave it at 0.0.0.0/0, then what that means is it's going to allow access from any IP address, but that's not what we want. So what I'll do is delete all of that right here. Now you can't see the IP address portion right here, but I did type it in, and at the end I have /32. /32 is basically a subnet identifier. By changing the subnet, we actually change how many IP addresses are within the scope of this rule right here. /32 means just one. There's just one possibility. There just isn't room for anything else. So by typing our IP address /32, what we're essentially saying is just this one IP address and no other IP address. That's what's allowed to access the server that we attach this rule to, at least via SSH. So anyway, I'll click Add. And now we have that rule. Now, one thing that I want to point out about using an IP address, like this one right here, is that if you don't have a static IP address, as you probably already know, that means your IP address can change at any time. If that's the case, then eventually this rule will no longer work. If your IP address changes to something else other than what you typed in for the rule, then what you'll have to do is go in here and update it. So that could be a little challenging if you don't have access to a static IP, but most organizations do, so that shouldn't be an issue in practice, but it is something that I wanted to make you aware of. But anyway, this rule now exists and we can apply it to an instance. So if we go up here to Compute and then back to Instances, and then we'll choose any instance we want. So I'll just choose the first one here, and I'll scroll down. And as you can see, we have an option that reads Edit Security Group. So if I click on that, and you've already seen this in the past if you remember this from a previous episode. But anyway, we have a list of security groups that are attached to this instance on the right-hand side. So these right here, these are currently attached to the instance. And if I wanted to remove one, I could click the minus button right here, which I'll do. And that'll move the security group away from this section and move it over here to the available section. So these are available and these are attached. And right here, we have the security group that we've just created. So what I'll do is add it to the instance. And then after that, I'll click Save. So attaching a security group is as simple as that. And unlike storage volumes, there's no one-to-one relationship required here. So what I could do is go to the second instance here, and I could do the same thing. I could take away this one here and click SSH access to apply that security group, and I could save it. And I could just keep doing that. For each instance that needs to be accessible in a similar manner, I could simply attach the security group to the instance, and that saves me from having to define the rules each and every time. And from here, you can get creative with security groups. You might create one for web servers, maybe another one for database servers, and that'll give you full flexibility as far as how those particular instances are accessed. You might have different rules for a database server compared to a web server, A file server will also be different, so you could define the security groups however you want to, and then apply them to your instances. But always keep in mind that you should always default to private unless the use case for a specific rule requires it to be made publicly available. Now, speaking of making sure that nothing is available publicly by default unless it needs to be, we should actually consider building our own private network. Now, I mentioned earlier the concept of a private network and a public network. In this example, I showed you how to make an instance publicly available or only available privately on your local network, but that in and of itself does not constitute a full private network or a full public network. When it comes to managing data centers, it's not uncommon to have a management network, and that network will not be available outside your organization. And that's important because if you put your management consoles on that network and you manage your networks, well, from that network, you certainly don't want that network to be accessible by other people that aren't authorized to access that network. So management networks are often created to separate access to servers or administrative access and then control how public services are accessed and separate public and private. That's very common. And not only is creating such a network a great way to become more familiar with networking in OpenStack, it also allows us to have a private network that we could use to better control outside access. And actually, that's exactly what we'll set up right now. We're going to create our very own private network, so let's work through the process. Again, at this point in the series, all of our instances are still publicly available. Of course, I just locked down SSH to my local IP here in my office, but we do have everything mostly publicly available. So to start the process, here's what we'll do. We'll go over here to Network, and then we'll click Networks right here. And what we can see right here is that we already have one network created for us, at least in my case. So to start the process, when it comes to creating an additional network, we'll click this button right here that reads Create Network. When we do that, this dialog box appears, the one that you see right here, giving us an opportunity to configure the network that we plan on creating. So the first thing we'll do is name the network, and I'll call mine Private Network 1, as you see here. And then next, what we'll do is click on Subnet, or we could simply click Next right here. It's basically the same thing. And this is where we actually set up the IP information for the network. So we also should name the subnet as well. So to keep consistent with the naming scheme here, what I'll do is call this Private Subnet 1. Simple enough. Next, we need to come up with a network address. This is how we actually set up the IP address scheme that we'll use for this network. In my case, what I'll do is type 192.168.0.1/24. The IP address scheme that you type here doesn't really matter, but in this case I just chose a simple network. A 192 network address scheme is very common, so I just went with that. If you have a different IP address scheme that you want to go with, that's totally fine. Now for the IP version, we'll leave it at 4, and then next our network will need a gateway IP. Without that, the instances within this network won't be able to communicate with anything. But actually, believe it or not, we're going to leave this blank. And the reason why is because Neutron will automatically provide this subnet with a gateway IP if we don't specify one ourselves. So what I'll do is let Neutron handle assigning this, and I'll click Next. And the last screen right here has some additional options that we can configure, but we're actually going to leave this blank. So what I'll do is scroll down here and click Create. And as you can see here, we have our private network. But those IPs are completely useless if we don't have something to control the routing of traffic. And this is not any different than a physical network. You're always going to need a router to route traffic. So to satisfy that requirement, what we'll do is create a router right now. And to do so, as you could probably guess, we'll click Routers right here. And to get started with creating a router, we'll click Create Router right here. That'll bring up yet another dialog box. And to keep with the naming scheme that I set up earlier, I'll just call this Private Router 1. Next, what we'll do is select the network that we want to use with this router. We're going to select an external network. So I'll drop this down, and I'll choose the only option that we have available. And this is the external network that was available in OpenStack by default. We didn't create this one, it was already there. but it's our only option anyway, so I'll click on that. Now, this external network is also known as the provider network, and the concept of a provider network is definitely something that we should understand. The provider network is actually beyond the control of OpenStack. You could think of a provider network as the next hop, as it's known, which basically means the next step of the routing process when traffic is on its way out of our OpenStack network. So basically, if a compute instance wants to communicate externally, for example, maybe your server needs to install updates, unless you maintain updates for the operating system yourself, which is very unlikely, then your server is going to need to download updates externally from the actual provider of those updates, and in order to do that, it needs external access. And that's what we're choosing here. If an instance needs access to the internet or an external network, what network is it going to use to get there? We only have one option, the external network, so that's why I chose that. Anyway, now that that requirement has been met, we can click Create Router to finalize the process. Now, what we should do at this point is add some additional configuration to our router. And to do that, we'll first click on it. We have the name of the router right here. It's the one that we've created. It's the only one in the list anyway. And more specifically, what we're going to do is go over here to Interfaces, and we're going to add an interface. So what we'll do is actually create an interface that'll connect to this particular router. So if I drop this down right here, we'll select the private network that we created earlier. When it comes to the IP address, what we're going to do is leave that blank. What that'll do is cause OpenStack to automatically use the gateway IP for this, which is fine for our purposes today. So let's click Submit. And we've just configured Private Router 1. How cool is that? Anyway, now that we have a new network, let's create some instances on that network. So to do that, what we'll do is go here to Compute and then back to Instances, which should look very familiar to you. We've actually went to this section many times in the series so far. What we're going to do is launch a brand new instance. And the goal here is to create an instance that's going to utilize the network that we've just created. So what I'll do first, just like last time, is give it a name. And since this is, I believe, the third instance that I've created, I'll just call this third instance. You can name yours whatever you'd like. So I typed in a description, as you can see. And I'm only going to need one instance here. I think that's good enough to show the example. We'll click on Source. We'll use an image as the source, and just like last time, what I'll do is create an instance based on Ubuntu 2004. So now we have that selected. For the volume size, I'll just set that to 16 gigabytes. For the flavor, I'll just randomly choose this one right here. It doesn't really matter for this example. And then we'll click on Networks. And this is where we're going to specifically choose the private network that we've just created. This will ensure that the instance that we're creating right now is created with a connection to that network in particular. Now, the remaining steps of the instance creation process will be exactly the same except for this part right here. Anyway, rather than click External and add that to our instance, what I'm going to do is add the new network to our instance, which is what I've now done. Now, continuing from there, I'll click on Security Groups. I want to add the SSH access security group that we've created earlier in this video. For the key, it's already created the J key that I've created earlier, since that's the only option that I have anyway. So far so good. What I'll do is click Launch Instance. And you know what? I'll go ahead and create a fourth instance as well. I'll just go through the exact same process again. I'll name it fourth instance. And then what I'll do is speed through the rest of the process here because you've already seen this. And now we have another instance that's coming online. That's pretty cool. At this point, what I'm going to do is connect to these new servers via SSH and install Apache, but we have a bit of a problem. These instances in particular are on our private network, which is fine since that's what we wanted, but we have no way of accessing these instances because, well, they're not publicly available. Even though we allowed SSH from our IP address in the security group, the private network is inaccessible from the outside. Now, if we click on an instance, I'll just randomly click on this one right here, and then I'll scroll down. You can see that we have a private IP address, but this IP address is not routable to the public at all. So unfortunately, there's no way that we can access this instance right now, but we can fix that. And one way that we could do that is by creating a floating IP address. In fact, let's do exactly that. But first of all, what exactly is a floating IP address? Well, a floating IP is an address that we can assign to an instance, and anytime we want to do so, we can remove an IP from one instance and move it to another. One reason why floating IPs are often used is for redundancy. Think of it this way. We have 2 servers right now. I just created 2 during the course of this video. And maybe we want to host our organization's public website here on OpenStack, but if that website is important to the business, we wouldn't want to have just one server. Perhaps we would instead prefer to have a second server that's set up exactly the same as the first. If the first server were to go down, we could move the floating IP address to the second instance, and then we could send users to that server instead. At that point, we could fix the first server and either leave the IP address with the second instance and have the first become the new redundant copy, or we could move the IP address back to the original instance. But the takeaway when it comes to the concept of a floating IP is that it allows us to assign an IP address to a resource and then move it around accordingly. So, you know what? Let's take a look at the process of assigning a floating IP right now. And to do that, we'll go back to the main section right here, and next to an instance we want to assign a floating IP address to, we'll click the down arrow right here, and then we'll click Associate Floating IP. Now here it's telling me that no floating IP addresses are currently allocated. So the first step then is to allocate an IP address. And to do that, we'll click the plus button right here. We'll leave the pool here at its default selection. We can also type a description if we'd like to. So I'll just give mine a simple description. I think that's good enough. In here, we can see that we're currently using 0 of 50 IP addresses that are available. So we have more than enough for this particular example. We only need one to illustrate the example. So what I'll do is click Allocate IP. And now we can see the IP address that's been allocated. Next, what we'll do is associate it to an instance. The instance that I want to associate it with is already selected for me, and that's because, well, I clicked the Associate IP address button that was right next to the instance that I wanted anyway, so it's already selected that for me. So what I could do is click Associate, and that'll finalize the process. Now, as you can see right here, we have 2 IP addresses. The first one is the private IP, and this one right here is going to be the public IP, the one that we allocated through the floating IP that we associated earlier. So now this instance has 2 IP addresses. And now that we have a private IP address, the one that I have highlighted here, then what that means is we can actually SSH into this compute instance. Before, we only had the private IP. And now we have a public IP that we could use to access the instance, so now the instance is accessible from the outside. So what I'll do is connect to each of the 2 instances that we set up, and I'll install Apache on those instances. But before I can do that, or at least before I can access Apache after I install it, I will need to open up port 80 at least, otherwise the security group will not allow me to access the instance. So let's take a quick detour. We'll go back to Network, and then we'll go to Security Groups. And we already have a security group that we could use for this particular purpose. We have Allow HTTP Ingress. We could also use HTTPS as well if we have a certificate or at least plan on setting one up. But for right now, I think this one is a good one to use. So we'll go back to Compute, and then we'll go to Instances. We'll choose the first one here. We'll actually click the drop down next to the instance. Let's edit the security groups. And these are the 2 that are assigned to the instance right now. So what I'll do is add this one right here. I'll save it. And now I'll do the exact same thing to the second instance here, or in this case, the first of the instances that we created during this example. I'll do the same thing again. Let's add HTTP and save it. So now at this point, we have each of the two instances that we created during the course of this video. But the floating IP address is assigned to the first one. This second instance here, or in this case, the third instance as I have it named, only has the private IP. So this one is not accessible from the outside because the floating IP address that we created is currently assigned to this instance. So I'll copy the IP address. Let's switch over to a terminal. And here's the most recent SSH command that we've used, at least in my case. So what I'll do is paste the IP address, the floating IP address right here, and that's going to enable us to access the server. So I'll press enter. Let's see what happens. So I'll say, yes, I do want to connect to the server. And I'm connected. Now, normally what we would do is make sure that all security updates are currently installed. I'll leave that up to you. I showed you the process earlier in the series, so there's no need to go through that again. We want to make sure that we always do that anytime we set up an instance. But we do want to install Apache for this example, so we will need to run sudo apt update to refresh our package repository index. We want to make sure that we do that at least once a day anytime we plan on managing packages on a Debian or Ubuntu system. But since we did run the apt update command, we should have an up-to-date cache of available packages. So what we'll do is run sudo apt install and then Apache 2. So I'll press enter, and this should go by fairly quickly. And now that's done. So let's actually set up the example. And this is going to be a lot of fun. So what we'll do is change into the /var/www/html directory. Now, if we list the storage of this directory, we have a file already right here that was created for us when we installed Apache itself. It's called index.html. And that actually is what creates the default start page that we see when we set up Apache for the very first time, something that we saw earlier in the series. But what we'll do is set up a fun example. Type sudo and then nano. I want to edit that file. And as a proof of concept, what we'll do is go to the very end of the file. And we'll find the last paragraph, which is going to be this one right here. So what I'll do is go to the end of the paragraph here, and I'll type another one. So what I've done is I've just added another paragraph tag here. I want to add something to differentiate this server from the other one. So what I've done is I've just added this line here that says hello from instance number 1. So what I'll do is save the file and I'll exit out. And that's all we're going to do for this particular instance right here. So what I'll do is disconnect from this instance. And now I'm back to my local command line. Now what we're going to do is configure the second instance. But first, what we'll have to do is move this IP address from this instance to the other one. It doesn't matter what order you do this in, but we certainly can't access this instance without a public IP. So what I'll do is click the down arrow next to the instance that we've already attached the floating IP address to. And then I'll click disassociate floating IP, which is going to remove it from this instance. And I'll leave the IP address itself alone. And I'll also make sure to not check this box right here. If I do so, it's going to delete the floating IP completely. We don't want to delete it, we just want to disassociate it, which means we're freeing it up to be attached to another instance. So again, we'll not check this, but we will click this button right here, and that'll finalize the process. Now, as you can see here, both of the instances that we've created through the course of this video both only have the private IP address now. So next to this instance, or whichever one you haven't configured yet in this video, We'll just drop this down. We'll click Associate Floating IP. And unlike last time, we already have an IP address that we can use for this purpose. So if I drop this down, I could select it right here. And we have the instance selected here that we're going to attach it to. It should already be pre-populated because we clicked the down arrow next to the instance that we wanted to configure in the first place. So we should only need to associate the IP by clicking this button. Now notice that the floating IP address is now attached to this instance and is listed right here. So let's go back to the terminal. What I'll do is click the up arrow to connect to the instance again. I'm going to leave the IP address alone because that didn't change. That's a floating IP address. But it doesn't point to the same instance as it did last time. So when I use this command now, I'm actually going to be connecting to the other instance. But we have a bit of a problem. It's giving us a warning. It's telling us that the host identification has changed. And usually when you see a message like this, it's warning you that there could potentially be a man-in-the-middle attack happening. That's when an attack is set up such that you're connecting to a completely different server than the one that you think you're connecting to. But in this case, this message is expected. If you do see this message when you didn't actually configure the IP address, that would be a problem, but we were expecting it this time. So what we could do is actually run the command that we see at the end right here. I'll just highlight it. So it actually gives us the command that we'll need to fix this. So I'll copy that and I'll paste it in. Let's run it. And that should fix it for us. So let's try this again. We'll try to connect. Let's see what happens. I'll say yes. And now I'm connected. We're going to do the exact same thing again. We're going to run sudo apt update. We'll refresh the package repository index. So that should happen pretty quickly. In fact, we're almost done. And just like last time, I'll ignore the updates on my side. I hope that you would have already gone through that on your end. That'll be a little bit of homework for you. But anyway, just like last time, we're going to run sudo apt install and then Apache 2. That'll get Apache installed. And now that's done. And just like last time, we'll navigate to the same directory. We have the index file right there. So we'll edit it. And again, go all the way to the end of the file. A little bit too far there. And right after the last paragraph tag, I'll add another one similar to how I did that last time. And I'll type the same message again, but I'll be careful to change the instance number. I just want to make sure that they're different in some way. Anyway, I'll save the file, and then I'll exit out. Now let's switch back to the browser. And I'll open up a new tab. And then what I'll do is paste in the floating IP address right here. And that brings us to the Apache 2 default page, just like we've seen earlier in the series. But I did add something additional to this page. So if I scroll down, right here, we see hello from instance number 2. That's pretty cool. So we know that this server is working. What about the other one? Well, let's go back to the OpenStack tab right here. And I'll drop this down just like last time. I will disassociate the floating IP address. And I'll go ahead and attach it to the first server here on the list. I'll select the same IP address from last time. I'll associate it. And now the process is done. So if I go back to the start page here, since this doesn't automatically refresh, we still have right here, hello from instance number 2. So what I'll do is refresh it now that I've changed the floating IP address assignment to the other instance. And you can see that it changed to hello from instance number 1. But why would you want to even do this in the first place? Well, it's not uncommon in a website to have something in the footer if you wanted to have some kind of identifier on the website itself that'll tell you which instance you're actually connected to. And that information could be helpful to you, the administrator. Now, you might not want to have that on a production website, but when you're developing one, well, I think that's actually a good idea. That way, you could test the floating IP address, make sure you could access each of the servers that the floating IP address is attached to, and then maybe when you're done developing whatever your solution is, you could remove this line if you don't need it anymore after that. But in our case, it actually proves to us that the floating IP address is working. I had it attached to one of the instances and it said hello from instance number 2, and then I moved it to the other instance, and the verbiage down here changed after I refreshed the page. So it's working. So at this point, we've manually built a private network. We also built 2 custom instances, and then we associated a floating IP address to the first instance, and then we did the same with the second one. So you're probably starting to see just how useful the concept of a floating IP address can be, if you weren't already aware of the benefits, that is. But this idea can be extended a lot further. For example, consider a load balancer. A load balancer might spread users evenly between 2 instances, or we can have a failover system in place such that the floating IP address moves to the other instance if there's a problem with the first one. And this is a great idea because what this saves us from doing is manually moving the IP address. That's what a load balancer allows us to do. In fact, why don't we set up one right now? So let's go back to Horizon and start the process. And to get started with that, we'll click on Network, and then we'll click on Load Balancers. Now, of course, we don't have a load balancer yet because we have yet to create one. So let's do that. I'll click Create Load Balancer right here. And I'll give it a name. And then for the IP address, I'll leave that blank. And then I'll give it a description, may as well. So I've typed that in. And for the availability zone, we'll leave that blank. Now we'll skip ahead to the subnet section here. And what I'll do is I will attach this to the private network that we've created. And we shouldn't need to configure anything else here. So what I'll do is click Next. That brings us to the listener details section. For the protocol, what I'll do is choose HTTP for that right there. That auto-populated port 80 in my case. So that's pretty cool. Let's click Next. When it comes to the algorithm, what we'll do is we'll choose round robin. And what that means, basically, is that traffic will be sent evenly between the instances that we have attached to this load balancer. We don't have any instances attached to this load balancer just yet, but once we do, then that's how traffic will be distributed among them. Basically, the load will be spread evenly among the servers. So I'll click Next. And then we could choose which instances are going to be a member of the load balancer. So what I'll do is add both of the instances that we've created over the course of this video. So I've added the first, and I'll add the second. We can see that each of those servers have been added. They're listed right here. For the port, we'll go ahead and choose 80 for both of these instances right here. And then we'll click Next. Now on the next page, what we'll do is set up the health monitor. And what a health monitor does for us is it determines whether or not an instance is fit to serve traffic. So to set up this health monitor, I'll change type to HTTP. And when it comes to the remaining fields, I'll just leave them at their default. I think that's good enough for this example. So I'll scroll down, and then I'll click Create Load Balancer. So now the load balancer has been created. And here's where everything comes together. What we're going to do is disassociate the floating IP address from the instance that it's currently attached to. So we'll take a detour real quick here to the compute section. We'll go to instances. And we can see that this IP address, the floating IP address, is assigned to this instance. So let's disassociate that. That'll free it up for us. We'll finalize the process. And as you can see, the IP address went away. So now neither of these two instances are accessible from the public. There's no way that we can SSH into these instances. But that shouldn't really matter because the floating IP address is something that we'll use to access these anyway, and we're going to do that through the load balancer instead of directly with the instances themselves. So let's go back to that section. We'll go back to load balancers. We have our load balancer right here. What I'm going to do is drop this down, and I'm going to associate the floating IP address to the load balancer instead of the instance directly. So we'll choose the same IP address that we've been using, and let's associate it. So now if we click on the load balancer itself, let's just check it out real quick. And if I scroll down, we have a floating IP listed right here. And that means that everything should be working properly. Let's go ahead and test it out. I still have the default page right here, and it's currently saying hello from instance number 1. So let's refresh the page and see what happens. So it still says number 1 right here. And check it out, it switched to number 2. And notice at the bottom that the instance number keeps changing. So even though I'm accessing this website right here from the same IP address each time, the load balancer is spreading the load between the two instances. So right now I'm connected to the instance that has the verbiage hello from instance number 1, and now I'm connected to the instance that has the verbiage regarding number 2. So now I bet you can see just why a floating IP address is so useful. Combined with a load balancer, it's even better. By itself, a floating IP address is a great way to keep one IP address associated with a service and apply that IP address to whichever compute instance is providing that service. With a load balancer, that actually happens automatically, so we don't have to manually move the IP anymore. The IP address is associated to the load balancer, so it's always going to work for us. And if one of the instances goes down, then it's going to stop sending traffic to that instance. That also gives us the capability of setting up redundancy, which is really cool. And with that said, this particular episode has come to a close. Just like with all the others, I really enjoyed creating this particular episode for you guys, but there's a few more coming, so definitely subscribe to Learn Linux TV, so that way you'll be the first to see those new episodes as soon as they come out, if they're not out already. Now, did you like this video? If you did, then please consider clicking that like button to let YouTube know that you like this video, and that'll help out the channel. But not only that, that might help spread OpenStack around YouTube, and I would love to see more OpenStack content on YouTube. That would be awesome. Anyway, again, thanks for watching this video. I really appreciate it, and I'll see you in the next episode.